Are biological processes usually irreversible processes? Have you ever wondered if biological processes can be reversed? This question is fascinating and dives into the heart of thermodynamics and life itself. Let's break it down together. Biological processes are generally considered irreversible. This means that once a biological process occurs, it cannot be undone without causing changes in the system or its surroundings. To grasp this concept, we need to look at the basics of thermodynamics. A process is labeled irreversible if it cannot return both the system and its environment to their original states without net changes. The idea of irreversibility is closely tied to entropy. Entropy measures disorder or randomness in a system. In any natural process, entropy tends to increase. This increase means that energy becomes less available for doing useful work. As entropy rises, perfect reversal of a process becomes impossible. Take metabolism, for example. It involves complex interactions at the molecular level and transformations of energy. These processes always produce some amount of entropy and dissipate energy, often as heat due to molecular friction and collisions. Because of this energy loss and increase in entropy, biological processes cannot simply be reversed to restore the original state exactly. You might think that some reactions in biology appear reversible. However, they often consist of pairs of separate irreversible steps that are catalyzed by different enzymes. So, even if a reaction seems reversible at first glance, the underlying molecular mechanisms are thermodynamically irreversible. Irreversible thermodynamics provides a framework to describe these processes. It focuses on how energy and entropy flow within living systems. This framework helps explain how biological order and function emerge, even with the universal tendency toward disorder. Understanding that biological processes are irreversible has practical implications. In fields like medicine, biotechnology, and environmental science, this knowledge guides how we design drugs targeting metabolic pathways. It also helps optimize biotechnological processes by minimizing energy waste. In essence, biological processes are usually irreversible because they involve energy dissipation and entropy production that prevent exact reversal. This understanding is fundamental to applying thermodynamic principles to living systems. It makes these concepts accessible to everyone interested in the science of life.